Good evening, and welcome tonight. I'd like to take you somewhere hidden, somewhere quiet, somewhere that most of the world never sees. Even though it has been there for years, resting beneath ordinary fields and quiet villages, beneath roads, beneath vineyards, beneath the soft and untroubled borderland between France and Switzerland. Far below the surface, under grass that bends in the wind, and under towns where windows dim, one by one, at night, there is a ring. It is enormous, but it is unseen. It is one of the largest machines human beings have ever made, and yet from above, almost nothing gives it away. A farmer can walk across his land, a cyclist can pass along a country road, rain can settle on the earth, birds can move through the evening air, and all the while, deep below, a perfect circle waits in the dark. Inside that buried ring, particles smaller than atoms ascend, rushing through emptiness at speeds so close to the speed of light that language begins to feel a little too clumsy to hold the idea properly. They race through cold tunnels, guided by magnets and silence. And when they meet in flashes, so brief and so small that no human eye could ever witness them directly. And yet, from those tiny vanishing moments, people have tried to answer some of the oldest questions we have ever asked. What is matter, really? Why does anything have weight? What was the universe like before stars, before planets, before oceans, before sleep, before memory? Tonight, though, there is nothing you need to solve. You do not need to remember every name. You do not need to follow every detail. You only need to let the shape of this hidden place unfold slowly around you. Because beneath those quiet fields lies not a place of panic, not a place of danger, not a place of noise, but a place of patient human curiosity, a buried circle built not to disturb the night, but to ask, as gently as a machine possibly can, what the universe is made of when everything familiar has been peeled away. So let your thoughts soften, let the room around you become a little dimmer in your mind, and imagine, just for a while, that somewhere under the sleeping border of Europe, a ring rests in the dark, waiting for us to descend. Before we go any deeper, let everything become simple. You are here, you are safe. There is no rush in this story, because this is not a story that needs rushing. It moves underground. It moves in circles. It moves with patience. It returns again and again to the same few wonders, each time from a slightly different angle, the way tired thoughts do when they begin to loosen and drift. So for a moment, do not think of a scientific facility or a research institution or a machine with a long official name. Think instead of entering a quiet place. Think of stairways leading down beneath the world of weather. Think of the sound of footsteps changing as the air cools. Think of concrete walls, dim work lights, long service corridors, doors that seal with heavy precision, and the odd, almost dreamlike feeling of standing inside something built at a scale so large that it stops feeling like machinery and starts feeling like landscape. Above ground, the night may be still. Below ground, there is another stillness entirely. Not the stillness of a forest, not the stillness of a bedroom, but the stillness of controlled conditions, of systems held in careful balance, of huge energies and exact alignments resting inside a world of metal, vacuum, electronics, and engineered cold. And yet, even here, there is a kind of calm that matters, because the hidden strength of this story is not really force. It is restraint. The machine below the fields does not roar like a volcano. It does not blaze like a furnace. It does not reveal itself all at once. It waits. It circulates. It gathers motion inside silence. Perhaps that is why it lends itself so well to the drifting mind. There's something soothing about a ring. Something soft in repetition. A circle has no hard conclusion. it returns where it began. It does not rush toward a sharp ending. It loops and loops and loops again, and far below the French-Swiss border. That is exactly what this machine does. It loops again and again around a buried circle. In the dark, if it helps, you can imagine that you are not studying it, but simply passing through it as a gentle observer. You do not need to stand under bright lights holding a clipboard. You only need to move slowly through the underground hush and let each part of this hidden world appear in its own time. First the idea of it, then the place itself, then the motion, then the cold, then the strange truth that by building one of the most intricate machines on Earth, human beings hope to glimpse a universe that existed before Earth had even been born. For now, though, we are only arriving, and arriving in a quiet story should never feel abrupt. So take one more slow mental step downward. Leave behind the fields, the roads, the fences, the moonlit roofs. Leave behind the ordinary map of the surface and enter the deeper map, the buried ring, the hidden tunnel, the patient circle waiting in the dark. The machine known as the Large Hadron Collider sits inside a tunnel about 27 kilometers around, or roughly 17 miles, curving in a near-perfect loop beneath the land. If you trace that distance in your imagination, it is enough to wrap beneath towns, fields, wooded patches, and the gentle folds of the countryside, forming a circle so large that no single underground chamber could ever contain it in one glance. You experience it in sections, in arcsy, in long stretches of corridor and pipe, in the repeated rhythm of infrastructure that vanishes into the distance. The tunnel is not a cave in the ancient sense. It does not drip with mineral secrets or twist in wild natural shapes. It is human-made, deliberate, measured, lined with the materials of engineering rather than geology. And yet, because it curves away beyond sight, because it lives in cool dimness, because it holds such a huge, invisible purpose, it still carries a little of the feeling of entering somewhere older than everyday life. There is a particular kind of wonder that comes from being underground and knowing that above you, the world continues normally. Cars move, dogs bark, someone closes a window, someone forgets to water a plant. Somewhere, perhaps, rain falls on a roof. And beneath all that, hidden from ordinary errands and ordinary worries, lies this circular corridor where human beings have spent years arranging metal. Magnets, cables, detectors, cryogenic lines, vacuum systems, and control equipment with astonishing care. The tunnel sits about 100 meters below the surface, in many places, deep enough to remain sheltered from much of the noise and movement of the world above. That depth matters physically, but it matters emotionally too. It gives the collider its special mood. It is not only large, it is secluded. Its true life happens out of sight. One of the easiest mistakes to make is to imagine the collider as one single dramatic room, a place where everything important happens in one obvious center. But it is not like that. It is a distributed world, a ring of many systems, a place of distances, a place where one section resembles another, and where repetition becomes part of the architecture. There is something almost monastic about that repetition. Pipe after pipe, support after support, cable tray after cable tray. The same curve, the same narrowing perspective, the same sense that if you kept walking long enough, you would never reach a final end, only another section of the same buried purpose. This is part of what makes the collider feel, in the imagination, less like a machine and more like a hidden environment. It is a habitat for precision, a climate of exactness, a long underground orbit where motion and stillness coexist. In some stretches, the tunnel gives you the sense of scale first. The ring is simply huge, too large to hold in ordinary intuition. In other stretches, the details take over. Bolts, brackets, labels, panels, insulation, railings, neatly bundled lines, all the small evidence that giant instruments are actually built out of countless ordinary parts assembled with extraordinary discipline. And here, in this long buried loop, the contrast becomes soothing. The grandest questions of existence depend, in the end, on connectors fitted correctly, on alignment checks, on seals that hold, on temperatures maintained, on teams of people who know which wrench to use, which reading matters, which sound is normal, which vibration means pause and inspect. When people imagine advanced science, they often imagine abstraction, equations floating in clean white air. But underground, the collider is tangible. It has surfaces. It has weight. It has corners and access hatches and maintenance spaces. It has places where technicians have stood and waited and checked and adjusted. The mysteries it pursues may be cosmic, but the place itself is built from practical labor. And perhaps that too is strangely comforting. That under the giant questions there is craft. That under the awe there is routine. That even in a machine meant to recreate conditions from the infant universe, someone still had to tighten fittings and label circuits and decide where a walkway should go. As we move deeper into the feeling of the tunnel, you may notice the story itself slowing. That is right, it should. A place like this deserves to be entered in the manner it exists. Gradually, steadily, without hurry. The collider does not reveal its meaning all at once. First, it is just a ring, then a tunnel, then a system, then a hidden route for things too small to see, and only later does it become a kind of time machine, though not in the playful storybook sense. More in the sense that by building a perfect circle in the earth, people found a way to ask the past to appear for one impossibly brief instant. But we are not there yet. We are still walking, still adjusting our eyes, still letting the underground space become familiar. So continue with me, a little farther into the curve. Let the tunnel bend ahead. Let its hidden distance calm you. Let the surface world drift farther upward and away, and in this long circular corridor below Europe, begin to feel the quiet strangeness of a machine built to send almost nothing around, almost forever. Inside the collider, the particles most often sent around the ring are protons, tiny pieces of atoms, smaller than anything the human eye has ever been able to see directly, smaller than dust, smaller than mist, smaller than the faintest imagined grain. And yet these minute particles are given a path that stretches for miles, as though the machine were a racetrack built for things that have no visible body at all. When the collider is operating, those protons do not stroll, and they do not simply drift. They race. They circle the buried ring at speeds so close to the speed of light that they can travel the full length of the tunnel more than 11,000 times every second. The number is almost too large to feel. 11,000 laps in a single second. By the time a person takes one calm breath in and out, a proton beam has already swept around the underground circle again and again, far beyond the reach of ordinary imagination. And yet, somehow, the image can still be made gentle. A ring in the dark, a stream thinner than a hair, a path repeated with perfect commitment. Again, again, again. There is a softness in repetition, even when the thing repeating is unimaginably fast. The beam itself is not a glowing ribbon you can watch with your eyes. Much of what happens inside the collider happens in invisibility. That too gives it its dreamlike quality. A great deal is occurring, but not in the dramatic style of sparks flying through visible air. Instead, the true motion is hidden inside pipes, guided by magnetic fields, measured by instruments, translated into signals and data and diagrams only later. So the mind is free to imagine it as a quiet current in the dark, a nearly weightless caravan of particles, a circling intention. Each proton in the beam carries energy, but that energy is packed into something so small that the scale becomes almost poetic. A thing too tiny to notice can be made to carry the concentrated consequence of an immense machine. It is one of the recurring lessons of the collider. At the smallest scales, the world is not less powerful for being unseen. Sometimes it is precisely in the unseen that power becomes most surprising. Still, the beam is not allowed to behave wildly. Everything about the collider depends on discipline. The path must be controlled. The focus must be maintained. The timing must be exact. Because it is not enough to have particles moving quickly. They must move in carefully organized bunches, steered through the underground ring with exquisite precision, prepared for moments when one beam will cross another and produce the fleeting encounters scientists have come to study. If you want a calmer way to picture it, imagine an orchestra that never lets its notes scatter. Or imagine a river made not of water, but of innumerable tiny intentions, all held inside a channel so perfect that almost none are lost. There is elegance in that, and also vulnerability, because the faster the beam moves, and the more precisely it is confined, the more the machine must protect the conditions that make such motion possible. Even the slightest disturbance can matter, even a small deviation, at these scales and speeds, can ripple into a larger problem. That is one reason the collider feels so unlike the brute force machines people often imagine. Its strength is not a heavy shove. It is a sustained act of fine control. A proton circling the ring is not simply being flung. It is being guided, corrected, held to a path that exists only because thousands of components remain in agreement with one another. And here the buried ring becomes even more beautiful in a sleepy way, because it begins to resemble not an engine of violence, but a choreography, a long dance in darkness, a repeated arc of motion. The same circle traveled at almost the greatest speed the universe allows, yet still dependent on balance, still dependent on care. If you sit with that image long enough, it starts to lose its sharpness and become strangely soothing, not because it is simple, but because it is consistent. The beam does not wander emotionally. It does not surprise itself. It follows the ring. It keeps the curve. It returns to the same geometry over and over. There is something in that which the tired mind recognizes. Thoughts, too, go in circles at night. Memories orbit. Questions loop. But here in the collider, the circle is built for a purpose so clean and exact that it almost offers relief. Here's a loop that is meant to be a loop. Here's repetition shaped into knowledge. Here is a circle that does not trap. It reveals, at least, that is the hope, because all this rushing around the underground ring is not an end in itself. The motion gathers significance only when two streams of protons are guided into meeting. When all the care of the machine narrows toward a point so small that the event itself seems impossible. Two nearly light-speed beams, two invisible currents, a collision, and from that brief instant, an opening. But before those meetings can happen, there must first be a passage clear enough for the particles to move through almost untouched. A path so empty that even space itself begins to seem crowded by comparison. The beams of the collider travel through pipes that are kept emptier than outer space. It is one of those scientific facts that feels almost too neat to be true, and yet it captures something essential about the machine. To guide particles cleanly around a 17-mile ring, the path cannot be full of interruptions. It cannot contain drifting air in the way an ordinary room does. It cannot allow wandering molecules to cross the beam casually like pedestrians stepping into a road. Nearly everything must be removed. So inside the beam pipes, Engineers create an artificial emptiness, a vacuum so deep that there are astonishingly few atoms left to interfere. If outer space is, in our imagination, the great emptiness, then the collider produces a narrow human-made emptiness, even more carefully scrubbed, a corridor of almost nothing extending for mile after mile beneath the earth. That is a lovely paradox, really. To study matter, they begin by making emptiness. To learn what particles do, they first remove almost everything else that might get in the way. The mind can rest in paradoxes like that, a giant machine devoted to creating controlled absence. The deeper we go into the collider, the more it becomes clear that science, at this level, is not only about what is added, it is about what is taken away. Noise removed, heat removed, resistance removed, stray particles removed, uncertainty reduced, as much as human hands and minds can reduce it. Inside the vacuum pipe, a proton can circle for long periods with remarkably little interruption. There is almost no friction in the ordinary sense, almost no clutter, almost no random encounter. The path is not just dark, it is clean to a degree that everyday life can barely imagine. And maybe that is one reason the image feels so restful, not because emptiness is cold or severe, but because it is simplified. Imagine a passage where almost nothing drifts. Imagine a road with no dust on it, no fog, no loose leaves, no insects, no weather, no sound, no unexpected crossing at all. Just path, just curve, just purpose, of course, creating and maintaining. Such a vacuum across a ring that large is not simple. Pumps, seals, monitoring systems, materials, procedures, all must work together. This kind of emptiness is not natural, and because it is not natural, it must be protected continuously. The artificial void has to be made and remade, watched and preserved, like a delicate condition rather than a passive absence. There is something almost ceremonial about that, a modern ritual of clearing space, of sweeping away interference so that the smallest travelers in the universe can pass undisturbed. At the human scale, we fill our rooms with objects and our calendars with obligations and our minds with unfinished fragments. We live inside clutter of one sort or another, but beneath the earth, inside the collider, an opposite world has been engineered. A world where the path is emptied, a world where a proton's journey depends on the absence of distraction, a world where almost nothing stands between one lap and the next. It is pleasant to remain with that idea for a while. A buried ring, an invisible beam, a pipe so empty that even space feels busy by comparison. And through that near-perfect emptiness, particles circling over and over, each lap another quiet preparation for a meeting not yet arrived. If the beam pipe is the clean road, then the magnets are the invisible hands that keep the travelers on course. Without magnets, the protons would not obediently follow the curve of the tunnel. Their natural impulse at those speeds would be to continue in straight lines. So all around the ring, the collider uses powerful superconducting magnets to bend, focus, and guide the beams, keeping them locked to the circular path. These are not ordinary magnets in the domestic sense. They are large, intricate, and immensely strong, designed for a task so exact that tiny deviations matter. They must bend the paths of particles moving at nearly the speed of light, without ever touching those particles directly. The work is done through fields, invisible structures of force, shaping invisible travelers in invisible motion. A machine of hidden guidance. There is something beautifully indirect about that. Nothing is pushed by hand. Nothing collides with a visible barrier to make the turn. Instead, a magnetic world is built around the beam, and within that world, the particles follow the path laid out for them. The result is almost ghostly, metal and cables and cryogenic systems on one side. On the other, a narrow stream of protons moving through darkness, held in place by forces no eye can watch. And for these magnets to do their work properly, they must be made extraordinarily cold. In fact, parts of the collider operate at temperatures close to absolute zero, around 19 Kelvin, colder than the deep emptiness of space between the stars. That sentence alone has a power of its own. Beneath ordinary villages, beneath quiet roads and sleeping fields, there exists a ring colder than space. The contrast is almost irresistible to the imagination. Above ground, summer sun can warm vineyards, autumn wind can move through trees, winter rain can soften the earth. Below ground, hidden away, a machine rests inside an artificial cold, so severe that ordinary electrical resistance falls away and superconductivity becomes possible. In that strange frozen state, the magnets can carry immense currents and generate the fields needed to steer the beams. This deep cold is not theatrical. It does not glitter for effect. It is functional, quiet, necessary, and perhaps that makes it even more evocative. The machine's power depends on a cold so complete that it almost feels like a form of silence. To sustain it, the collider relies on one of the largest cryogenic systems ever built. Liquid helium circulates through the system, carrying away heat, preserving the conditions required for superconductivity. There are pipes within pipes, thermal shields, insulation, pressure controls, all part of a hidden climate engineered beneath the land. If the previous image was of emptiness, this one is of cold. An underground ring of near-perfect emptiness and near unimaginable chill. And yet from this cold come collisions hotter than the center of the sun. That contrast sits at the heart of the collider's strange beauty. The coldest ring allows the hottest flashes. The most controlled stillness allows the briefest recreation of cosmic fury. But the cold itself deserves a quieter look. Imagine walking beside the machine, knowing that inside those great line sections lies metal, held at temperatures so low that the ordinary rule of everyday experience feel far away. The surface might not announce its inner condition dramatically. You would not see icicles and winter frost in the cartoon sense. Instead, you would know that hidden within the carefully insulated structure is a temperature that belongs less to Earth than to some abstract edge of physical possibility. That knowledge changes the feel of the place. It becomes almost lunar, almost interstellar, and still, it remains underground, built by people, maintained by teams, dependent on schedules and expertise and maintenance plans. Again, the collider balances the vast and the ordinary, the extraordinary state of matter maintained by completely practical work. Because such cold cannot be casual, it must be sustained and protected. If a magnet warms unexpectedly and loses superconductivity, a quench can occur. Resistance returns. Energy must go somewhere. Heat rises where it should not. Protective systems must respond. The machine that appears so steady reveals how delicate its balance truly is. And yet, the very existence of those protections is calming in its own way. This is not reckless science. It is science living inside watchfulness. Temperatures monitored, currents measured, systems designed not merely for performance, but for care. The deeper you listen to the collider, the more it sounds like attention itself. A ring where nothing is left unobserved for long. A ring where fields guide particles and liquid helium preserves cold and instruments stand ready to notice the first sign of drift. Below the world of moonlight and weather, below the surface map of farms and border roads, lies this cold, precise circle, a place where the smallest things are given a clear path. place where invisible motion depends on invisible force, a place where near absolute cold quietly supports one of humanity's warmest ambitions, to know a little more about what all this is. But even the most carefully tended machine is not beyond failure, and one of the ways the collider became what it is now was by stumbling, early on, in a way that forced everyone involved to learn more deeply how to care for it. Not long after the collider first began operating, an accident interrupted its early promise. An electrical fault led to a serious incident involving superconducting magnets, and the sudden loss of their delicate state. What had been imagined as the beginning of a smooth new era of discovery became, instead, a reminder of how finely balanced the machine really was. The accident itself is often described in technical terms, but beneath those terms lies a simple truth. A giant system, operating under extreme conditions, can be vulnerable in tiny places. A small problem can become a larger one. Heat where there should be cold. Stress where there should be stability. Damage spreading farther than anyone wanted. When the failure came, it caused significant harm. Equipment was damaged. Helium escaped. Repairs would take time, effort, and humility. The great underground ring that had promised to reveal the universe's secrets had to pause and accept, in a very human way, that even brilliance is not immune to early mistakes. There is something almost tender in that, not the damage itself, of course, but the lesson embedded in it. The collider did not simply break and vanish into embarrassment. It was studied, repaired, improved, strengthened. People went back through the machine, section by section, to understand what had happened and how to prevent it from happening again. Safeguards were upgraded. Monitoring became better. Weaknesses were addressed, not with despair, but with patient work. In that way, the collider's early accident began to resemble many other human stories. A grand beginning interrupted, confidence replaced by repair, a hidden flaw revealed, then slower wisdom. It is easy, especially at night, to imagine great scientific projects as somehow untouched by ordinary emotional rhythms. But they are built by people, and people know the shape of disappointment. They know the feeling of plans delayed, of hope checked by reality, of going back to the drawing board and beginning again, not because beginning again is glamorous, but because it is necessary. So beneath the technical history of the collider lies another history, the history of persistence. A machine like this does not become real all at once. It is revised into reality. It is tested into maturity. It becomes trustworthy by surviving the need to become more careful. And when the collider returned to operation after that long period of repair and improvement, it did so not as a machine that had never faltered, but as one that had already learned one of the oldest lessons in engineering. Precision is not simply designed, it is earned. There is a calm dignity in that kind of recovery. You can almost feel it in the underground ring, a sense that the machine below the fields is not naive anymore. It knows its own demands. It knows what vigilance costs. It knows what happens when tiny things are neglected. And so in the beam circle now, when the cold is sustained, and the vacuum holds, and the magnets guide the path, all of that smoothness contains memory. Not memory in a human heart, perhaps, but memory in design, memory in added protection, memory in procedures changed, memory in systems made wiser by a difficult beginning. The sleepy mind can rest with that, a machine that was not perfect from the start, a machine that stumbled, a machine that returned, and beneath that story, another quiet reassurance. The world's deepest questions are not always approached through grand triumphs alone. Sometimes they are approached through repair, through patience, through the refusal to abandon the circle simply because the first turning was not as graceful as hoped. So the collider remains there, in the dark, not untouched by failure, but tempered by it. Its ring still curves beneath the earth, its cold still holds, its beams still circle, and all that care, all that correction, all that exactness now prepares the machine for the briefest and brightest moments at its heart. When beams meet inside the collider, the energy of their motion is squeezed into an incredibly tiny space and released in a way that briefly echoes conditions from the earliest moments of the universe. That is one of the most extraordinary facts about the Large Hadron Collider, and it is easy to say quickly, but perhaps much better to linger with slowly. The early universe was not calm. It was not made of stars and oceans and long weather patterns. It was dense, hot, energetic beyond everyday comprehension. The familiar structures we live among had not yet formed. Matter, as we know it, had not yet settled into stable arrangements. The universe was young in a way that almost resists imagination. And yet, deep underground, with all this careful machinery, human beings have found a way to create miniature flashes that reproduce a tiny hint of those early conditions. Not for long, never for long, only for the briefest instant. That brevity is part of the wonder. Everything the collider does is aimed, in one sense, at making something fleeting enough to disappear almost immediately, but meaningful enough to leave traces behind. The collision itself is not a spectacle one watches directly. It is an event inferred from what follows. Sprays of particles, penergies, signatures, captured by detectors built to notice what no naked senses ever could. Still, before the data and the analysis and the graphs, there is the image. Two streams of protons, each prepared and guided through the ring, crossing one another at selected points. A meeting, a release of concentrated energy, a tiny flash of conditions that belong more naturally to the dawn of the cosmos than to a tunnel beneath Europe. There is something humbling in how small the doorway is. We like to imagine revelation as huge. Mountains parting, skies opening, thunder and proclamation. But here, revelation comes from minuteness, from one controlled collision among countless others, from a burst so brief that, by the time we speak of it, it is long gone. Perhaps that is why the collider feels less like an instrument of conquest and more like an instrument of listening. It does not seize the early universe and hold it still. It coaxes from matter a brief reenactment, a tiny echo, then studies the fading evidence. And though the temperatures reached in such collisions can be described as hotter than the center of the sun, the overall mood of the machine remains strangely tranquil, because the heat is not spread through rooms or corridors or night air. It is local, momentary, microscopic. It arrives and vanishes faster than thought can form around it. What remains afterward are traces, patterns, clues, a whisper that something ancient briefly returned. This is one of the great sleepy pleasures of the collider as a subject. It asks us to imagine time folded inward, not literally traveling back, but creating conditions so primitive that for a fraction of a moment, matter behaves as it did when the universe itself was almost newborn. And then that moment is gone, a flash, a vanishing, a puzzle left in the detector. Some collisions are ordinary by the collider standards. Many produce outcomes that fit well with what physicists already understand. But hidden among the countless routine events are the rare ones that matter deeply, the ones that may reveal something subtle, something unusual, something not yet fully seen. That is why the repetition matters so much, why the beams circle and circle, why billions of collisions can occur, why data accumulates like a patient snowfall. because rare truths often do not arrive on command. They must be waited for, prepared for, detected when they finally flicker into being, and all of it depends on the machine we have already entered in our minds. The buried ring, the vacuum, the magnets, the cold, the repaired wisdom of early fail. All of that infrastructure exists so that somewhere at certain points along the underground circle, two invisible streams can meet and briefly light a path backward toward the beginning. The mind may begin to drift here, and that is all right. This part of the story invites drifting, ancient heat appearing in modern darkness, the first universe hinted at beneath sleeping fields, a ring colder than space making flashes hotter than stars, and from those flashes, human beings hoping to understand how the universe once was, before it became the calm and structured place where, tonight, you lie listening. In some of the Collider's most special runs, scientists accelerate not only protons, but heavy ions such as lead nuclei and smash them together. These collisions can produce an exotic state of matter called quark-gluon plasma, a state so strange and so ancient in character that it belongs not to the ordinary world around us, but to the universe before ordinary matter had quite settled into being. To appreciate that, it helps to soften the familiar picture of atoms. We tend to think of matter as made of stable pieces: atoms, nuclei, protons, neutrons, the furniture of existence arranged in a reliable hierarchy. But in the very early universe, before enough cooling had occurred, even those structures were not yet living the lives they live now. Quarks and gluons, the more fundamental ingredients, moved in a freer, hotter, more fluid state. The collider, for a fleeting instant, can bring some of that back. Not in a grand cosmic ocean, of course, only in tiny droplets, tiny fireballs, tiny regions of extreme condition. But even that is enough to matter enormously, because if you can create and study such a state, even for an instant, then you can ask how it flows, how it cools, how it gives way to the more familiar building blocks from which everything else will later arise. And what physicists found was one of the story's loveliest surprises. The quark-gluon plasma did not behave simply like a random gas of chaos. In many ways, it behaved more like an almost perfect liquid, a fluid with astonishingly low viscosity, flowing with a kind of smoothness that challenged earlier intuitions. That image is worth pausing over. The earliest matter in the universe, not merely explosive, but fluid, not just violent, but flowing, not only a chaos, but a smooth and nearly perfect liquid state, carrying within it the first conditions from which all later structure would emerge. There is something deeply dreamlike about that. We begin with fire and arrive, oddly, at liquidity. The first universe, in one of its aspects, becomes less like shattered debris and more like a searing sea. A sea before stars, a sea before atoms, a sea before the sky knew how to be dark, and beneath the earth, human beings have briefly made tiny versions of that ancient sea and watched the traces it leaves behind. If you let the imagination rest inside that image, the collider becomes almost mythic, not in a false sense, not in a fantasy sense, but in the sense that it sits at the edge of origin stories. It reaches toward the oldest layer, physical memory, toward a time when the ingredients of reality had not yet hardened into the world we know. The detectors surrounding those heavy ion collisions do not see a glowing little ocean in any ordinary visual way. They see aftermath. They see showers of particles, distributions, momentum, patterns. But through these, physicists infer the fluid properties of the plasma. They learn that the earliest matter may have been smoother, more collective, more elegantly flowing than many had expected, and that changes the emotional tone of the beginning. Instead of imagining only a universe born in pure violence, we can imagine one that, even in its extreme youth, had textures of movement, subtle properties, rhythms of cooling, pathways toward order. The mind finds that easier to rest beside, a perfect liquid of the early cosmos, tiny droplets of the ancient universe made for an instant beneath Europe. The first material chapter of everything, revisited in miniature, and then lost again before a heartbeat could finish. This is one of the places where the collider becomes more than an instrument and begins to feel like a bridge not across distance, but across deep time. A bridge from our heavily furnished universe back toward its less formed self. And because this state is so short-lived, it gains an added softness. It is not held in place or frozen for display, it appears. Flows, cools, vanishes, like breath on glass, like a dream that lingers just long enough to tint the waking mind before disappearing. Perhaps that is why people are so drawn to the idea of the collider, even when they do not fully know the equations behind it. Gives form to a beautiful intuition that reality remembers more about its own beginning than we can see on the surface, and that if we build carefully enough, listen quietly enough, and wait patiently enough, some of those first memories can still be coaxed into view. So beneath the earth, in a machine of emptiness and cold, there are moments when matter briefly loosens itself and becomes something older than atoms, something smoother than expectation, something like the first liquid of the cosmos. And from those brief returns, the story of the universe becomes just a little less hidden. Among all the discoveries associated with the collider, none became more famous than the Higgs boson, the particle linked to the field that helps give fundamental particles their mass. It is easy to say those words with the confidence of hindsight, but for decades the Higgs existed as a missing piece in theory, an elegant idea waiting for experimental confirmation. Its importance can sound abstract at first, so perhaps it is kinder to approach it slowly. Why does matter have weight in the way it does? Why are some particles massive while others are not? Why does the universe permit stable structures rather than leaving everything as a restless flood of pure energy? The Higgs field, as physicists understand it, offers part of the answer. It is not a little substance sitting in one corner of space. It is a field that fills space, and particles interact with it in different ways. Those interactions help determine the masses of fundamental particles. The Higgs boson is the detectable sign, the quantum ripple, the particle associated with that field. In other words, finding the Higgs boson was not merely finding one more entry in a long particle catalog. It was confirming that one of the key mechanisms in our understanding of nature is real. But Higgs boson itself is fleeting beyond ordinary comprehension. It does not sit around politely waiting to be photographed. It appears and decays almost immediately into other particles. No one sees the Higgs directly in a simple visual sense. Scientists reconstruct its presence from the patterns left behind when it breaks apart. That reconstruction took immense patience. The signal was rare. The background noise was enormous. Billions upon billions of collisions had to be studied. And what emerged in the end was not a theatrical explosion of certainty, but a subtle excess in the data, a bump in a graph, a small and persistent sign that something was there where theory had long predicted it should be. There is a wonderful humility in that. One of the greatest discoveries in modern science arrived not as a giant obvious revelation, but as a slight rise on a statistical landscape, a whisper in noise, a gentle insistence, a pattern that refused to disappear as more data came in. Perhaps that is how many truths actually arrive, not as fanfare, but as a soft irregularity that keeps surviving doubt. When the collider's great detectors, especially ATLAS and CMS, independently found evidence for a new particle, consistent with the Higgs boson. The moment was historic. It completed a major missing piece of the standard model of particle physics and brought decades of theoretical work into experimental reality. Yet even the emotional core of this achievement can be told in a sleepy way, not as triumph blaring trumpets, but as the quiet fulfillment of a long wait. Imagine proposing something subtle about reality in the 1960s and living long enough to see a buried ring beneath Europe finally produce the evidence. Imagine years of uncertainty, years when the idea remains beautiful but unconfirmed, and then, at last, the graphs appear. A small bump in the right place, enough significance, enough independent agreement, enough patience rewarded. The discovery mattered because without the Higgs mechanism, the world we know would not take shape as it does. Atoms would not settle in the same way. Structure would be unrecognizable. Stars, planets, chemistry, bodies, rooms, blankets, breathing listeners in the night, all depend on the fact that the universe did not remain a featureless sea of light and raw energy. And so the Higgs, despite being fleeting, points towards something steady, the quiet architecture of existence. The reason matter can gather itself, the reason the world has heft. It is strangely moving to realize that one of the things making your own body possible was once a predicted field, then a hidden particle, then finally a confirmed part of nature through the work of thousands of people and one buried machine. The collider did not create the Higgs field, of course. That field was already woven into reality. What it did was reveal the particle signature that confirmed the theory in a way nature had long kept hidden from easy view. Again and again, the collider teaches the same emotional lesson. The universe is under no obligation to make its deepest workings obvious. If we want to know them, we may need giant circles under quiet fields, impossible cold, cleaner than space emptiness, billions of collisions, and years of interpretation just to hear a whisper. The sleepy mind can love a whisper. A whisper does not demand. A whisper invites, and the Higgs boson entered public imagination almost like that. A long-sought sign emerging from statistical patience, transforming a buried machine into a symbol of humanity fulfilled. Still, for all the importance of the Higgs, the collider did not become less interesting after finding it. In some ways it became more interesting, because one great answer has a habit of sharpening the outlines of even larger unanswered questions. The collider has confirmed part of the story, but beyond the Higgs, the universe still keeps much of itself in shadow. For all that human beings have learned, most of the matter we can see may account for only a small fraction of what exists. Galaxies turn as though hidden mass surrounds them, like bends in ways that suggest invisible structure. The cosmos behaves as if it contains far more than stars. Dust, gas, planets, and everything those things include. We call that missing component dark matter, though the name is really a placeholder for ignorance wrapped in a useful phrase. We know something is there by its gravitational effects, yet we do not know exactly what it is made of. We do not know whether it will fit neatly into known theories or demand a new framework entirely. Collider has been one of the instruments used in that search, not because it can see dark matter directly in the way a flashlight sees a chair, but because if collisions create particles that slip away without interacting with the detectors in ordinary ways, their absence can leave a pattern, missing energy, imbalances, signs that something was produced and then escaped into invisibility. There is something almost ghost story gentle in that. Not a visible creature, only a missing footprint in the measurements, a silence where something should have spoken. The same is true, in a different way, for the question of antimatter. According to our best understanding, The early universe should have created matter and antimatter in nearly equal amounts. And yet the universe we inhabit is overwhelmingly made of matter. Somehow, somewhere, there was an imbalance. A tiny excess of matter survived, and from that excess came stars, planets, oceans, histories, rooms, and listeners. Why, it is one of the deepest and most intimate scientific questions imaginable, because it is really asking why there is something rather than almost nothing at all. Experiments at the collider, especially LHCb, study subtle differences in how matter and antimatter behave. Tiny asymmetries, slight biases in decay, small departures from mirrored perfection. The hope is that these clues may lead toward understanding why matter endures. Again, the pattern repeats. Immense questions approach through delicate traces. Not thunder, not proclamation, a slight asymmetry, a rare decay, a missing balance. The collider has also been used to search for other possibilities once spoken of with enormous theoretical hope. Supersymmetry, extra dimensions, unknown particles beyond the standard model. So far, none have announced themselves with clear certainty, and that absence is its own kind of information. Sometimes science advances by finding the expected. Sometimes it advances by not finding it. The failure of a hoped-for particle to appear does not mean the machine has failed. It means reality has not yet agreed to be simple. It means the map is incomplete. It means the dark remains dark, and therefore interesting. There is a sleepy comfort in open questions. A finished world is a smaller world. An unfinished universe still has room to breathe, so perhaps it is enough tonight not to solve dark matter or antimatter or hidden dimensions, but simply to feel how the collider extends human attention into those mysteries. It does not promise all answers. It offers a refined way of asking. A ring in the dark, still turning, a machine listening for things that leave no ordinary trace. A machine asking why matter stayed. A machine wondering what fills the hidden majority of the cosmos. And between each question, a soft return to the buried tunnel, to the cold, to the curving path under the fields, where everything continues with patient care, even when the universe declines to answer quickly. At several points around the collider's ring, giant detectors surround the places where particles collide. These detectors are among the largest and most sophisticated scientific instruments ever built, and although each has its own design and focus, all of them serve a shared purpose: to catch the aftermath of events, too small and too fast for direct human perception. It helps to imagine them not merely as machines, but as architectures of attention. Atlas, one of the largest, is so immense that people often compare it to a cathedral. The comparison is not only about size, though it is indeed enormous. It is also about mood. A detector like Atlas has layers upon layers, structures within structures, a volume so large and so full of purpose that it can feel almost ceremonial. Not religious, perhaps, but reverent in its own way. A place built to witness tiny truths with grand patience. CMS, another of the great detectors, pursues many of the same goals, but through a different design philosophy. Where Atlas spreads wide in one style, CMS compresses power into another. It is denser, compact in a relative sense, and built around a very strong magnetic field that helps bend the paths of particles so their properties can be measured with exquisite precision. Together, Atlas and CMS formed a kind of double watch during the search for the Higgs boson. Each looked at collisions independently. Each built its own case. And when both saw compatible signs of the new particle, confidence deepened. One detector alone can suggest. Two great detectors agreeing can persuade. Then there is Alice, designed especially to study the quark-gluon plasma created in heavy ion collisions. If Atlas and CMS are broad witnesses to many possibilities, Atlas is more like a specialist listener, tuned to the strange fluid matter that briefly reappears when nuclei slam together at extreme energies. Through Alice, the Collider's story turns again toward the earliest universe, toward the first liquid sea of quarks and gluons. LHCb, meanwhile, watches with a different emphasis, concentrating on particles containing bottom quarks and on the subtle asymmetries that may help explain the matter-antimatter imbalance of the cosmos. Its geometry reflects its purpose. It is not trying to be all things at once. It watches the aftermath from a chosen angle, asking one of the most quietly enormous questions in physics. Why are we here at all? What unites these detectors is not only their scale, but their role as intermediaries between invisible events and human understanding. A collision happens. It is over almost instantly. The particles born from it race outward, and the detectors, with layered systems of sensors, trackers, calorimeters, magnets, electronics, and timing devices, record what they can. Not the event itself in simple human terms, but the evidence, the footprints, the energetic residue. There is something touching about the fact that human beings built giant underground eyes, because nature would not let us see directly. The detectors do not watch in a human way. They do not marvel. They do not blink. They do not drift. But their existence is an extension of human longing to know. We cannot stand beside a collision and watch the Higgs boson appear with our own eyes. So we build cathedrals of instrumentation to do the seeing for us. And because they are so large, these detectors introduce a wonderful change of scale into the story. Particles are tiny beyond intuition. The events are brief beyond language, yet the instruments built to study them are monumental. Heavy, cavernous, almost architectural in their presence. Tiny event, enormous witness. That contrast never really stops being beautiful. It also prevents the collider from becoming emotionally flat. Just when the mind may begin to float away into abstractions of beams and fields and symmetry, the detectors bring us back to material form. Great chambers underground, vast cylinders and layered structures. People standing beside components that dwarf them, engineering at the scale of buildings, all devoted to occurrences smaller than atoms. The sleepy mind can rest in that disproportion. Something little, something huge, something vanishing, something built to endure. The detectors wait where the beams cross. They keep their stations in the underground dark, and when the tiny flashes come, they gather the evidence. Patiently, tirelessly, over years. If the detector halls are the cathedrals of this story, then the sensors within them are its countless small listeners. A modern particle detector contains millions of sensing elements. Some track the passage of charged particles with astonishing precision. Some measure energy deposited in layers of material. Some distinguish among different kinds of particles based on how they move, how they interact, how they lose energy, how they decay. Each component contributes a fragment, and from these fragments, physicists reconstruct what happened in a collision that has already vanished. In that sense, the detector is not one eye, but a vast community of tiny eyes. Millions of fast decisions, millions of electronic notices, millions of local responses woven into a larger picture. This is one of the Collider's most hypnotic qualities. It turns the invisible world into a problem of traces. Nothing stays long enough to be looked at leisurely. Everything must be inferred from what it leaves behind. A curved track here, a deposit of energy there, a shower spreading outward, a timing signal, a directional clue, piece by piece, event by event. A hidden story is rebuilt. But there is an even greater challenge. The collider produces an overwhelming amount of information. Enormous torrents of raw data pour out from the detectors when collisions occur. Far more than can possibly be stored in full. Far more than any ordinary system could calmly gather without drowning. So the collider uses trigger systems, layers of filtering that decide in real time which events may be worth keeping and which must be let go. This happens incredibly fast. Signals are examined almost immediately. Obvious routine events are discarded. More promising events are passed to deeper analysis. The stream narrows. The flood becomes a filtered river. There is a severe practicality in this. Most collisions are not special. Most are not the rare doorway to a new particle. Most are not the subtle asymmetry that changes a theory. If everything were saved, the very abundance of data would become unusable. So the machine must forget, constantly and efficiently. That is a startling idea, and maybe a strangely human one. To discover the rare, you must let the ordinary pass by. To hear the whisper, you must not cling to every sound. The collider's filtering systems do not do this carelessly. They are designed with physics in mind, tuned to recognize patterns that might signal something unusual. High-energy signatures, rare decay products, configurations worth a closer look. Increasingly, machine learning and advanced algorithms assist in this work, helping sift through the vast sea of events for the ones most likely to matter. Yet even with all that sophistication, the process remains humbling. Most of what happens is discarded. Most flashes vanish unkept. Nature speaks constantly, and we keep only a tiny fraction of the conversation. Still, the fraction we keep is enough to transform understanding, and the data does not stay in one place. The collider depends on a worldwide computing network, a distributed system linking universities, laboratories, and research centers across the planet. Information recorded at CERN flows outward to many countries, where analysts and students and researchers process pieces of the whole. In that way, the underground ring extends far beyond its tunnel. It becomes a global web of interpretation that, too, is restful to imagine. Not science as a lone genius in one room. Science as many hands, many screens, many minds, all quietly sharing the burden of attention. Somewhere a detector records a rare event. Somewhere else, perhaps across an ocean, someone studies its traces. The ring under Europe becomes a world-spanning act of thought. And despite automation, despite AI, despite staggering computational power, the final act of understanding still returns to human judgment. People inspect plots, question anomalies, compare models, test assumptions, repeat analyses, argue gently, wait for enough evidence, submit to peer review, seek not speed, but confidence. It is almost the opposite of the noisy myth of instant discovery. The collider's truths are slow truths, built from many signals, filtered through many systems, carried by many minds, and always, beneath it all, the buried ring keeps circling in the dark, generating events, letting most of them go, saving the rarest few, and offering them up to a planet-sized community of patient interpreters. For all the grandeur of the machine, the collider is also deeply human, not because it behaves like a person, but because it is the result of vast cooperation across borders, languages, specialties, and decades. No single mind could build it. No single team could maintain it. No single nation could claim its entire meaning. The Large Hadron Collider is one of those rare creations that genuinely belongs to a larger human project. The attempt to know more than any one life could know alone. Thousands of scientists, engineers, technicians, analysts, and support workers have taken part in its making and operation. Some worked on magnets, some on cryogenics, some on software, some on vacuum systems, some on civil engineering, some on detector design, some on electronics, some on alignment, some on theory, some on data analysis. Some entered the story for a short phase and left. Some spent whole careers there. The machine gathers not only particles, but human time. And that time is not all spent in moments of discovery. Much of it is spent in maintenance, upgrades, calibration, review, testing, and preparation. Collider's history includes long shutdowns when the beams stop and the tunnel becomes a place of careful labor again. Magnets are improved, components replaced, detectors upgraded, cables rerouted, software refined. The future is prepared piece by piece. There is something deeply honorable in that hidden work. The public tends to notice the big moments, the first beam, the famous discovery, the striking headline. But beneath every headline lies years of quiet effort that almost no one celebrates outside the field. Countless hours under fluorescent work lights, countless checklists, countless measurements repeated to ensure that when the machine awakens again, it can do so safely and precisely. In recent years and decades, the collider has also been evolving toward the high luminosity HT, a major upgrade intended not mainly to raise the collision energy dramatically, but to increase the number of collisions over time, multiplying the data available for rare processes. In a sleepy way, this is a very beautiful idea. Not bigger drama, more patience, more statistics, more chances for rare truths to rise clearly from noise. It is an upgrade in persistence. The future of the collider is not simply one louder machine. It is one more capable of waiting well, of accumulating more, of sharpening the view through abundance. And because the machine is so precise, even the Earth itself becomes part of the story. The tunnel must remain aligned within tiny tolerances. Ground shifts, temperature changes, subtle geological motions. Even the tidal influence of the moon and sun can matter at the margins. Sensors watch, adjustments are made. The buried ring is not isolated from the planet. It lives within it and must constantly respond to the small breathing motions of the world that holds it. That image is hard not to love. A machine of almost impossible precision tucked inside a living Earth that rises and falls by small amounts under the pull of celestial bodies. The moon affects the sea, and somewhere, in a more delicate way, the moon also tugs on the great scientific ring below the fields. It reminds us that no technology is ever fully outside nature. Even our most advanced instruments remain held within the rhythms of the wider world. Perhaps that is part of why the collider feels less threatening and more poignant when described slowly. It is not a rebellion against the universe. It is a conversation with it. A very elaborate, very disciplined, very expensive conversation, yes, but still a conversation. One in which human beings admit they do not know enough and decide, together, to build a machine that might help them ask better questions. And what is true of the machine is true of the community around it. Collider is not one person being brilliant in isolation. It is shared curiosity organized at scale. It is trust between disciplines. It is international patience. It is a distributed act of attention. Somewhere in South America, a student might analyze a dataset. Somewhere in Asia, a team might refine a model. Somewhere in Europe, an engineer might test a component for the next upgrade. Somewhere in North America, a physicist might compare a result across channels. The ring underground is local. The thought around it is planetary. So when we speak of CERN or the collider, we are really speaking of a worldwide mind gathered around a buried circle, listening for whispers from the beginning of time. Late at night, the collider can begin to feel almost too mythic. And that is perhaps why myths have gathered around it. Whenever human beings build something large, hidden, and difficult to understand, The imagination begins to fill the dark around it with strange possibilities. Over the years, the Large Hadron Collider has inspired anxieties that ranged from the dramatic to the absurd. Some feared it might create catastrophic black holes. Some imagined tears in reality. Some spoke of portals, doomsday, cosmic accidents, or the end of the world triggered from beneath the French-Swiss border. The machine became, in certain corners of the imagination, less a scientific instrument than a symbolic threshold where anything frightening might occur. It is not hard to see why these fears found an audience. The collider is underground. It is huge. It deals with particles. It speaks in energies and forces and conditions from the early universe. For someone standing far from the actual science, those ingredients can easily blend into a story that feels half laboratory and half underworld. But the quiet truth is much more measured. The collider is powerful, yes, but not uniquely beyond nature itself. High-energy particle collisions happen in the cosmos without human permission. Cosmic rays strike Earth's atmosphere with energies that can exceed those produced in the machine. The universe has been performing energetic experiments for eons, and the planet remains here, calm enough for grass to grow above the collider's tunnel. This matters, not only scientifically, but emotionally, because the true story of the collider is not that humanity recklessly built a doomsday device beneath some innocent fields. The true story is that humanity built an exquisitely monitored, deeply studied, carefully regulated instrument to recreate tiny, fleeting conditions already permitted by nature, and then surrounded that instrument with oversight, review, and caution. The myths often say more about human fear of the unknown than about the machine itself. And perhaps that is a gentle lesson in its own right. When we cannot see what lies below the surface, we invent, we project, we dramatize. A tunnel in the dark becomes a portal. A detector hall becomes an altar. A scientific question becomes an omen. But if we remain with the place long enough, if we walk its curves slowly and let its systems come into view, the fear begins to dissolve. The ring is not waiting to swallow the world. It is waiting to measure. The detectors are not watching for apocalypse. They are watching for traces. The beams are not circling toward doom. They are circling toward data. In fact, one of the most charming things about the collider, once the myths fade, is how much of it is made from ordinary virtues. Patience, care, checking, refining, upgrading, collaborating, thinking twice, reviewing one another's claims, testing again, proceeding slowly where slowness protects accuracy. That is not the temperament of a nightmare machine. That is the temperament of a very careful question. And yet, I would not want to dismiss the myths entirely, because in their own distorted way, they reveal something real about the collider's emotional power. People sensed, correctly, that the machine touched beginnings, touched hidden layers, touched conditions the everyday world does not display. They felt the pull of mystery. They simply wrapped it in fear rather than wonder. Tonight, perhaps we can unwrap it gently. Beneath the fear is awe. Beneath the rumor is scale. Beneath the dramatic language is a quieter and more beautiful truth. A buried ring where human beings ask ancient questions with modern tools, not to break the world, but to understand why the world exists in the shape it does. So let the myths pass like old weather. Let the imagined portals close. Let the doomsday stories fade into the distance, and keep only the softened outline of the truth. A circle below the earth, a machine colder than space, invisible beams moving through cleaner than space emptiness. Detectors like underground cathedrals, tiny flashes carrying hints of the first universe, and thousands of patient people listening for answers that may arrive only as whispers. Now, as the story eases toward its ending, it is time to return to the ring itself. Not the headlines, not the theories, not the fears, just the ring. Somewhere beneath quiet fields, it remains. The tunnel curves through darkness, whether anyone on the surface is thinking about it or not. Villages settle into sleep, border roads empty. Morning dew will someday gather above it. Seasons will turn, leaves will fall. Snow may come and melt. And below all of that, the hidden geometry stays in place. There is a comfort in imagining that continuity. The world above changes hour by hour. The ring below keeps its curve. Sometimes it is active with beams and collisions and streams of data moving outward to the world. Sometimes it rests during upgrades and maintenance. But whether active or paused, it continues to exist as one of the strangest and gentlest monuments to curiosity ever built. A ring not for conquest, a ring not for spectacle alone, a ring for asking what reality becomes when broken open carefully enough. Perhaps that is why it lingers in the mind after the facts begin to blur. You may not remember every number or every detector name or every theory mentioned tonight. That is all right. Sleep stories are not meant to be examinations. They are meant to leave behind a mood, a shape, a few images that drift pleasantly through the fading light of attention. So perhaps the image that remains is simply this: a quiet countryside at night, nothing dramatic visible on the surface. Below it, a circle. Inside that circle, almost perfect emptiness. Within that emptiness, invisible particles moving in patient loops. Around them, magnets and cold and sensors, and decades of human labor. At certain points, tiny meetings. From those meetings, clues. From those clues, a slightly clearer sense of how the universe once began. That is enough. More than enough, really, because what the collider finally gives us is not only scientific knowledge, but proportion. It reminds us that the familiar world is built on layers we do not normally feel. White matter, symmetry, imbalance, hidden mass, ancient plasma, fleeting particles, all beneath the surface of ordinary life. The chair in a room, the road under a bicycle tire, the hand resting on a blanket, all are rooted in deeper stories than they seem to tell. And yet, those deeper stories do not make the ordinary world harsher. If anything, they make it more tender, to know that stable matter had to come into being, to know that a symmetry may have allowed existence to persist, to know that fields silently give mass to particles, to know that beneath Europe a machine was built to glimpse some of this. All of that makes the quiet room feel a little more miraculous, not less. So if your thoughts are loosening now, let them loosen completely. You do not need to hold the whole story. You only need to let the ring remain somewhere in the distance of your mind. Far below, cool and patient, a circle in darkness, a question still turning, and perhaps that is the hidden loop that makes a story like this want to be heard again. Not because it ends with a final answer, but because it leaves one door open. The collider has discovered much, but not everything. The Higgs was found. The early plasma was studied. Precision has grown, yet dark matter remains hidden. Antimatter's imbalance remains only partly understood. New physics, if it waits beyond the standard model, has not yet stepped fully into the light. So the ring remains relevant. The questions remain alive. The machine remains, in a quiet way, unfinished. And unfinished things are often the easiest to drift beside, because they do not close hard around the mind. They stay open, they leave air, they let the imagination float. Somewhere in the future, more collisions will happen, more data will be gathered, more rare events may rise from noise. The detectors may see something unexpected, or they may continue refining what is already known with ever greater care. The upgrades will continue. The global network of minds will continue. And beneath the fields, the buried circle will continue waiting for the next beam, the next run, the next whisper from matter. You do not need to follow it there tonight. You can leave it underground. You can let the scientists keep watch. You can let the detectors listen. You can let the protons circle without your help. All you need now is the soft outline of the place, the cool feeling of descent, the long bend of the tunnel, the hidden emptiness in the pipes, the impossible cold around the magnets, the tiny ancient fires at the collision points, the giant underground eyes collecting traces, the myths fading, the truth softening, the ring still turning somewhere below. And as the story thins toward sleep, perhaps the best way to end is not with a conclusion, but with a return, back above ground, back to the surface, back to the quiet fields. Imagine standing there at night, not needing to know exactly where every section of tunnel runs, not needing to understand every detail of every system, only knowing that below you there's a circle made by human effort and human longing to understand. The grass is still, the villages are quiet, the sky is dark enough for thought to thin. Nothing in the landscape looks extraordinary, and yet the extraordinary is there, hidden under the ordinary, as it so often is. That may be the gentlest lesson of all. Most of reality's deepest structures do not announce themselves loudly. They lie beneath, they hold, they wait, and sometimes, if we listen in the right way, they become part of the calm rather than a challenge to it. So let the buried ring settle farther away now. Let it become less a scientific facility and more a slow, quiet circle beneath the world. Let the details blur pleasantly. Let the names grow softer. Let the machinery fade into the simple feeling of something vast and patient, resting under sleeping land. And as your own thoughts begin to move in wider, slower circles, you can leave the collider where it belongs, in the deep, cool dark below the fields, still keeping its curve, still holding its questions, still tracing its invisible loops, while the night above grows quieter and quieter. There is nothing left to solve, nothing left to follow, only the image of a hidden ring, deep under the earth, turning through silence while the rest of the world sleeps. And perhaps, somewhere far below, in that controlled and careful darkness, a few tiny particles are still circling their path, preparing for another brief meeting, another fleeting whisper from the beginning of everything. But you do not need to wait for it. You can rest now. You can drift. You can let the question remain in the earth. You can let the circle keep turning without you. Good night.